Hi there. Today what we're going to be doing is looking at, sorry about the weird rectangle. We're going to be looking at applying the law of sines. We'll need a calculator today, so we can get that out. And today what we're going to do is kind of practice the ambiguous case, which we looked at in the last lesson. So let's kind of review the idea of using the law of sines and when we can do that in the different triangles. So anytime that you have two angles in one side, which is the AAS case or the ASA case, what that means is that one triangle can be formed and that we can use the law of sines. Now, when we have two sides and one angle, which is SSA, we have to be careful. If we have the given angle that is obtuse, okay? And again, if we find that the side opposite is smaller, that's an issue and there is no triangle. If the angle's obtuse and the side opposite, which is what they give you, is bigger, there's one triangle good, okay? I tell you that a smaller side is across from an obtuse angle, that doesn't make any sense. We also said that there is a domain error, what that means is that there is, again, no triangle. So if we get a domain error, that means that there's no triangle. Now, if we get an answer, however, and the given angle is acute, what we have to do is we have to test the quadrant 2 angle. Because again, what we said is that our calculator, when we use inverse sine, is only going to give us the angle in quadrant 1, but it's possible that there's an obtuse angle that it could be in quadrant 2 that the calculator doesn't give us. So that's what we have to do, all right? So remember, the quadrant 2 angle is when we take 180 degrees minus the calculator angle, okay? And then again, what we see if the quadrant 2 angle plus the original angle that they gave us in the problem is less than 180 degrees, then that means that there are going to be two triangles that there is, okay? So let's just kind of go to work with that. And I think as we go through and practice, hopefully we'll see what we can do there. Okay, example 1, it says to solve triangle ABC, where the measure of angle A is 127 degrees, A is 63 and B is 42. So I know most of my triangles look the same, but here's my triangle with an obtuse angle. Look at that at 127. So I'll call this ABC. Side A is 63 and side B is 42. All right. So we have that, and we see that our opposite side is longer than the other side when it's obtuse. Okay, so we see that this is an SSA question. We see that it's obtuse, and we see that the opposite side is bigger. Okay, so what that means is that we're all set and we can proceed, and there's one triangle. You don't have to write all this stuff out. I'm just kind of letting you know like what should be going on in your head since I can't read that, all right? So then we could go ahead and start setting that up, but we know that there's just one triangle since it's obtuse angle and the side opposite that is larger than the adjacent side, and that makes sense since the larger side should be across from that bigger angle. So then we'll just set it up, 63 over the sine of 127 degrees equals 42 over the sine of B. We'll do our cross multiplying. We can see that the sine of B should be 42 times the sine of 127 degrees over 63. And that means that in the calculator that we will have to, blue box, take the inverse sine to find what angle B is. So I'm going to take the inverse sine of 42 times the sine of 127 over 63. And that gives me that the measure of angle B is about 32.2 degrees if I'm rounding to the nearest tenth like we have been. Okay. Because there's one triangle, I wouldn't bother finding another angle. Like if you did find another angle, you would take 180 minus 32.2. Clearly we can't make a triangle with that. There's clearly not enough degrees. So again, there's just one triangle, just trying to save you from having to do that. So now that we have two of the three angles, we can take 180 minus the original 127 minus the 32.2, and that tells us the third angle of the triangle, angle C. So the measure of angle C is going to be 20.8 degrees. And now that we have the measure of angle C, we're able to set up another proportion with the law of sines. Again, so these were the two matching pieces, the angle and the side opposite that angle. So I'll take 63 over the sine of 127 degrees. And then I'm going to find side C over the sine of 20.8 degrees, which is what we just found here. And so if I find C, when I think about cross multiplying, that would be 63 times the sine of 20.8 degrees all over the sine of 127 degrees. So I can put that in. So 63 times the sine of 20.8 over, the sine of 127. Again, we're not looking for an angle. We're just looking for C, so we don't need any inverse stuff. And to the nearest tenth, that would be 28.0. And so we have solved example 1. Let's try the same thing in example 2. This time we have triangle ABC where B is 52 degrees and across from A is 6.5 and across from B is 4.7. Okay, so we have an acute case. So this is an SSA acute case. So we have to basically set it up. And then there could be 0, 1, or 2 triangles. So let's set that up. 4.7 over 52. Again, I chose that as the ratio to start with since I had a matching angle and side. So 4.7 over the sine of 52 degrees equals 6.5 over the sine of A. So if I cross multiply, I have that the sine of A equals 6.5 times the sine of 52 degrees all over 4.7. So let's see what that looks like. So again, because I'm looking for the angle, and you could, if you forget and you type in 6.5 times the sine of 52 over 4.7 and you get something like this, just realize that you would have to then take the inverse sine of that answer. Uh-oh. When we try to find the measure of angle A, we get a domain error. And what that means is that there is no triangle that is possible. So that's kind of nice. Those are quick. And that's really all you need to say. Okay. Obviously, we want to see what led you to that conclusion. All right. In the last example, well, the last one on the first page here, it wants us to solve triangle ABC with the measure of A being 62 degrees. Let me just draw it real quick. Here's ABC. Measure of angle B is 62 degrees. Side A is 32 and side B is 34. Okay. So once again, this is an SSA case. We have an acute angle. So what that means is that we have to set up and test. Because there could be there could be 0, 1, or 2 triangles there. So let's set it up. I've got angle A and side A that I'm going to use as my base ratio here. So I have 32 over the sine of 62 degrees. And then side B is 34 over the sine of B. Okay, so then I have that the sine of B equals 34 times the sine of 62 degrees over 32. And again, I could just take the inverse sine of all of this, or again, if you forget, you can take 32 times, just kidding, 34 times the sine of 62 over 32. And then again, that's giving you the sine of B. So to find angle B, you would need the inverse sine of that. And so what that tells me is that angle B is about 69.7 degrees. Okay, so because there is an answer that's possible that we got here, we have to remember that our calculator only gave us the possible acute angle. It's possible that there is an obtuse angle that lives there as well. I'll kind of draw that here, all right? So this is what our calculator gave us, is this 69.7 degrees. It's possible that the 69.7 degrees lived in quadrant 2, and that we're really looking at this angle right here, okay? So this is where we get an answer. The given angle is acute. We're going to test that quadrant 2 angle, which is 180 degrees minus what we got in our calculator. And that gives us this obtuse angle right here. So we're going to call this the quadrant 2 angle. That would be the measure of angle B. So the quadrant 2 angle B would be 180 degrees. Oops, not times. 180 degrees minus 69.7. So that gives me about 110.3 degrees. Now the question is, can I use this quadrant 2 angle and the original angle and make a triangle? So let's test that. So can we take the quadrant 2 angle plus the original angle? The original angle they gave us was this 62 degrees. And is that less than 180 degrees? And we can see that that is going to be less than. You could punch it in if you wanted, but I see that's just going to be like 172.3. So this is true. And since that's true, that means that we have 2 triangles that we're going to deal with. Now, I know we looked at that the other day, but what that means is that we're going to have 2 different sets of answers. So I'm going to start just by dealing with this part here, with the measure of angle B, okay? So I know I'm going to need 2 triangles. I'm going to hold off on this just for a minute. Let's ignore this for a hot second and go back to this idea of the 69.7 degrees. We knew that our original angle was 62. So when we think about putting 69.7 degrees for angle B, to find our third angle, angle C, we would have to take 180 degrees minus the given 62 minus the 69.7. And that gives us the third angle of the triangle, which is 48.3 degrees. And now we can use the original proportion, 32 over the sine of 62 degrees. This angle C that we have here, the sine of 48.3 degrees. And we can use that to find our side C. So we have that C equals 32 times the sine of 48.3 degrees over the sine of 62 degrees. Again, we just punch that in. And that gives me that side C is about 27.1. Okay. So that's one possibility for our triangle. But we have another possibility too. It's also possible that instead of being an acute angle that measures 69.7 degrees, that angle B is an obtuse angle that measures 110.3 degrees. So I also want to happy cloud this as an answer. But I can't have 2 angle B's. I need to distinguish between these triangles. So I'm going to go back, and in these first ones, I'm going to call this B sub 1, C sub 1, and then side C sub 1 here. So that way I don't get it confused with this other possibility, which I'm going to call B sub 2. So let's think about if this angle B was the angle in question. Well, I have this original angle A of 62 degrees. So what I would do is take 180 minus 62, but now minus this 110.3. And this gives me another measure of angle C. And that angle, I don't know if you saw it, sorry, was 7.7. Okay, and because that we got that from B2, we're going to call that angle C2. And then again, we'll set up our proportion 32 over the sine of 62 degrees. And now we're going to use the sine of 7.7 degrees and side C2. So it's a different triangle that we have there. Okay. So we can see that by cross multiplying, C2 is going to be 32 times the sine of 7.7 over the sine of 62. So we have 32 times the sine of 7.7 degrees over the sine of 62. So that gives me that C2, oops, sorry about that, is about 4.9. So we have two sets of answers that are here. One possible triangle is that we have angle B that measures 69.7, an angle C that measures 48.3, and an angle C that measures a side C that measures 27.1. Or angle B is obtuse and it is 110.3 degrees. Then the little angle C is 7.7 degrees. And then side C2 is 4.9. Okay, so let me kind of try to demonstrate, show you visually, like how we would get two triangles. Give me 1 second. Okay, all right, so this is a little website that's just giving us an example here of this SSA case. So notice that they have this angle that is 30 degrees, and you can have any angle that's there, any acute angle that's there. And we have a side opposite, that's A, and then that side B. So that's an SSA case. So we can see right now that A isn't quite long enough to make a triangle. That's what happens when we get the domain error and we have a situation that's no triangle. That's what happens, okay? And so what I'm going to do is kind of change the length of A a little bit. Oops. And there is a possibility, hang on, where there is just one triangle that could be formed, okay? But notice that if we have, as we increase the length here, we have two different triangles that are possible. One triangle is here at A, B sub 1, and then this C that's here. So this darker blue triangle, do you see how angle B1 here is this obtuse angle? That's the quadrant 2 angle that we're finding. So this is that second triangle we're forming. The other possibility is this angle A, this angle B2, and this angle C, which they didn't label because it has the same vertex in this drawing. But you see that this angle C is bigger than, like when the triangle was obtuse over here on the left, this angle is so tiny. But if we just have the angle that the calculator gives us here, oh, I can pause it. Let's do that. If I just use the angle that the calculator gives us, I have this big triangle, A, B, C, that I'm looking at. And so then we have this angle C that we could find. So I wanted to demonstrate to you really what we were doing. We're really looking at this idea of this big triangle that's here, okay, versus this small, this obtuse triangle that's here. It's really pretty, I know. Okay. But those are the two different triangles that we're finding in these cases. Okay. Okay. Hopefully that worked. Okay. Before we go on to the U-try questions, I kind of have like one additional question I want you to look at. Because we didn't really discuss in detail what happens when it's SSA and it is one triangle. So I'm going to give you an example of what could happen here. Let's say that you know that the measure of angle A is 42 degrees and that side A is 22 and that side B is 12. Okay, so again, we can have this triangle that's here. We can have this ABC where this is 42 degrees. This is 22, and then side B is 12. I know in the picture I just showed you, B was going this way, but again, triangles can be turned all over the place. So we see it's an SSA case that's acute. So what we would do is we would take 22 over the sine of 42 degrees, again, because these are the matching angle and side opposite that angle. And then we'd have 12 over the sine of B. Then we could cross multiply and say that the sine of B is 12 times the sine of 42 over 22. And we would put that in the calculator. So again, we could inverse sine the whole thing right away if we wanted. 12 times the sine of 42 over 22 gives me about 21.4. So the measure of angle B is going to be about 21.4 degrees. Well, we need to test, remember, to see if we have a second angle that's possible, like a second triangle that's possible that I just showed y'all. So what we would want to do is take the 180 minus the 21.4 degrees to see what that quadrant 2 angle, what that obtuse angle would be. So another possibility for the measure of angle B would be 158.6 degrees. Okay, so now is it possible for me to make a triangle with those 158 degrees and the 142? Well, let's take a look. We could take the 158.6 degrees plus the given 42 degrees. Is that less than or equal to 180? And I think you guys are seeing that this is going to be more than 180 degrees, isn't it? 158.6 plus 42 gives me 200.6. This is not true. So what happens is that this is too big. That obtuse angle can't fit in that triangle. And so what that means is that there's only one triangle that's possible. So there's only one measure of angle B that we can have. We could then find the measure of angle C by taking 180 minus 42 minus 21.4. That's where the obtuse angle is hiding. The measure of angle C then is about 116.6 degrees. And there doesn't have to be an obtuse angle, but I don't want you to think that any obtuse angle won't work, okay? It's just that this quadrant 2 angle wouldn't work in this situation. There's only one triangle. And so then we end up with, let's see, our ratio is 22 over the sine of 42. Then we can have side C over the sine of 116.6. So C is going to be 22 times the sine of 116.6 over the sine of 42 degrees. So we're just going to take 22 sine 116.6 over the sine of 42. That gives me that C is about 29.4. And again, there's just one triangle that's possible, and that's it. So there are cases that are SSA that have just one triangle that are acute. I just wanted to demonstrate to you. Sorry, my computer cut me off. I think I was all set with that idea though. So that's the idea of if you only have one triangle. So I'd like you guys to do these you try questions. I'm going to work through them quickly, but I want you to press pause and try them on your own, okay? So go ahead and do that, and then if you have issues, I'll work through them with you. You guys, I said to press pause. Don't wait for me. Okay, bye. Okay, well, hopefully you actually press pause and you did these on your own, but let's reveal what the answers should be. This is going to be, just for time's sake, these are all SSA cases. This is one with an obtuse angle. And I see here that this is what would be across from that. And I see that it is bigger than that other side. So I see that this is going to be a case where we have one triangle, which is nice. So we can just set this up as normal. 18 over the sine of 122 degrees is 12 over the sine of angle B. So the sine of angle B is 12 times the sine of 122 over 18. Find that in my calculator. The measure of angle B should be about 34.4 degrees. Okay. Subtract both 122 and 34.4 from 180. We get that the measure of angle C is 23.6 degrees. And then I can set up a new proportion using the sine of 23.6 degrees and side C. So C, I cross multiply, is 18 times the sine of 23.6 over the sine of 122. And when I put that in my calculator, I end up with about 8.5 for my side C. Okay. I see that this is an SSA case as well. I see that it's acute. And what that means is that I'm going to need to test, to double check. Okay. So I've got this information here. So I can set that up. 9 over the sine of 36 degrees equals 12 over the sine of B. So I have that the sine of B is equal to 12 times the sine of 36 degrees over 9. And we find that the measure of angle B is about 51.6 degrees. Since we get an answer, we have to check quadrant 2. So let's look at my quadrant 2 angle B. My quadrant 2 measure of angle B would be 180 minus 51.6, which would be 128.4 degrees. So what happens if I try to add that quadrant 2 angle with my original angle that was given, 36 degrees? Is it less than 180 degrees? It is. So that means we have two triangles. So that means I'm going to call this B1, and I'm going to start dealing with that. If I happy cloud this one, I get confused right away. So I'm going to start with this measure of angle B1. So then I can subtract from 180. So 180 minus 36 minus 51.6 to get that measure of angle C1. That ends up being 92.4 degrees. And then I can set up my new ratio, well, the original ratio, my new proportion, I should say, with the new angle C as the measurement. And that's a 9, not an A, sorry. So C1 is going to be 9 times the sine of 92.4 degrees over the sine of 36 degrees. And it turns out that that side C1 should be about 15.3 degrees. Okay. Now I'll just color code. I'll do it in blue. Hopefully you can see the difference. So now I'm going to call this the measure of angle B2. That's going to be 128.4 degrees. So then I can take 180 minus the 36 minus this angle B, and that gives me the measure of my new angle C, which will be 15.6 degrees. And then I can set up a ratio again. with this angle C, which is 15.6 degrees, and the side C2. So C2 is going to be 9 times the sine of 15.6 degrees over the sine of 36 degrees, which, should end up giving us about 4.1. So all 6 of those pieces are your answers there. This is one of the triangles that's possible. That would have been that, like the larger triangle that you saw in the GeoGebra applet. And the other triangle is this one here. That would have been that smaller obtuse triangle that would have been on the left. That's there. Okay. Okay. And then we have letter C, and we have an SSA case where it's acute. So that means I'm going to need to just set it up and see what happens. So I have my original ratio of 2.8 over the sine of 50 degrees. That should equal 4 over the sine of B. So I'll see that the sine of B is 4 times the sine of 50 degrees over 2.8. So let's see what that gives me. Oh, I did it already. I'm stupid. What happens is I get a domain error. And those are nice because then our answer is no triangle and we can move on with our day. Okay, so that's the gist. I really like doing it this way instead of all of those rules that I was kind of telling you to ignore the other day that that some of the classes do. Again, some of the classes do all of these different rules where you have to do all this thinking, where I really feel that when we approach it this way, that we're really thinking a little bit more about the big picture than like memorizing if this, we're actually thinking, okay, I know that sine is possible to be positive in quadrant 2. What could that obtuse angle look like? And you're using the idea of the triangle sum theorem. Is this possible to happen? I just think it just ties it in a little nicer. So anyway, that's that. So good luck on your work with the law of sines, the ambiguous case. Have a great day.